We continue our unit on logarithms. Let's look at the definition of a logarithm. If b and n are positive numbers, b is not equal to 1, then log base b of n equals k if and only if b to the k power equals n. Let's write each equation in exponential form. Put a circle around the little base 2. The base of the log is the same as the base of the exponent, so I'm going to write 2 as a base to my exponential expression. Raise the 2 to the third power, and that is equal to 8. 2 to the third equals 8. Let's do the same with number 2. Put a circle around 2, draw an arrow to the negative 2, and then draw an arrow from the negative 2 to the 1/4. Starting with the base of the log, this is the base of my exponential expression. Raise it to the negative 2 power, and that is equal to 1/4. Number 3. Circle around 2, raise it to the 0 power, and that is equal to 1. Number 4. Circle around 3, that is the new base, raise it to the 4th power, and this is equal to 81. You try the next two. On number 5, we get 16 raised to the 1/4 power equals 2. And this makes sense if we go back to an earlier unit where we have the base raised to power over root. Then we have 16 raised to power over root. And if we rewrote that, we get the 4th root of 16, which is equal to 2. So this makes sense. And on number 6, we get 8 to the 1/3 power equals 2, or the cube root of 8 equals 2. Now we're going to use the same process and write each equation in logarithmic form. Circle the base of the exponent. The base of this exponential equation is the same as the base of the log, so this is log base 2 of 16 equals 4. Number 8. Log base 2 of 1/2 equals -1. Number 9. Log base 32 of 2 equals 1/5. Next expression. Log base 8 of 64 is equal to 2. Now you try the next two. And 11, log base 5 of 1 equals 0. And 12, log base 6 of 6 equals 1. Now we're going to evaluate the following logarithms without using a calculator. So we're going to use the information we know to help us with something we don't know. Now we just learned that we can rewrite this logarithm to be 5 to some power equals 25. Well, 5 squared equals 25, so the blank is 2. Log base 25 is equal to blank. Let's pretend like this blank is an x. 5 raised to the x power equals 25. From last unit, we learned that we can also change this 25 to be 5 squared. So now that the bases are the same, we set the exponents equal to each other, and x is equal to 2. 14. 4 raised to some power is equal to 64. Well, 4 to the 3rd power is equal to 64. But if we did not get that, or we don't remember, then we can use what we've already learned. 4 raised to some power equals 64. Let's put in an x for that blank. 4 raised to x equals 64. From here, we just need to get a like base. So I can change 64 to be 4 raised to the third power. Now the bases are the same. We set the exponents equal to each other and solve. 4 raised to some power x equals negative 16. Let's think about this one for a moment. If we put in a 0, 4 to the 0 power is equal to 1. If we put in a 2, we get positive 16. If I put in a negative 2, I get 1 over 4 squared, which is equal to 1 over 16. Is it possible for me to take a power of a number and get a negative number? No. So this problem has no solution. Number 16. 10 raised to some power x is equal to 10 to the third power. Well, this one's easy. X is equal to 3. Number 17. 3 raised to some power x equals 1/3. Well, this one I just need to manipulate my numbers. 1 over third can be rewritten 3 to the negative 1. So x is equal to negative 1. So this blank is really negative 1. Number 18, 9 to some power equals 3. I can rewrite 9 to be 3 squared, but I still have to multiply 2 to the x. And 3 is really 3 to the first power. So now I set the exponents equal to each other, and x equals 1/2. Number 19. 16 raised to some number x equals 1/2. If I bring 2 to the top, its exponent becomes a negative. 16 can be rewritten as 2 to the fourth power, but I still have to multiply the 4 to the exponent that's already there. So now that the bases are alike, we can set the exponents equal to each other and solve. So x equals negative 1/4.